Mathematics is strange. Sometimes it gives answers that feel more unbelievable than magic itself. Take this infinite sum 1 plus 2 plus 3 plus 4 plus and so on. If I ask this in a classroom, almost everyone would say the same thing. The sum blows up to infinity. And honestly, they would be right because the numbers keep increasing forever. Add more terms, the total keeps getting larger without any limit. So far, everything feels normal. But in the 18th century, one mathematician dared to play with the infinities in a way nobody else could. His name was Leonhard Euler, one of the greatest mathematicians in human history. Euler was famous for seeing patterns where nobody else could, sometimes brilliant, sometimes controversial. And while working with infinite series, he began writing equations that looked absolutely insane. One of those equations eventually became one of the most famous statements in all of mathematics. 1 plus 2 plus 3 plus 4 plus and so on is negative 1 upon 12, an infinite sum of positive natural numbers somehow giving a fraction, that too a negative fraction. At first glance, it feels impossible, almost like a joke. In fact, when most people first see this result, they assume mathematics has completely broken down. But here is the twist: this result actually appears in serious mathematics, quantum physics, and string theory. So, no, mathematicians are not claiming that the ordinary sum literally equals negative 1 upon 12. Instead, under very special interpretation, this divergent series can be assigned that value. But today's video is not about proving this result. Today's video is about something much more dangerous. How easy is it to create a fake mathematical proof that looks convincing enough to fool people? Let's begin. Let me call the infinite sum P. 1 plus 2 plus 3 plus 4 plus and so on. Separate out the even terms and the odd terms, and from the even terms, factor out 2. You will end up getting 2p here and the odd terms here. Now, rearrange the terms and you'll end up getting negative p is the sum of odd natural numbers. So, let us consider the largest odd natural number is 2n minus 1 and your n tends to infinite. The sum of first n odd natural numbers is n square, and when you apply the limit, it gives you infinite. Therefore, we can conclude that the summation p is equals to negative infinite. The answer is completely different from the result proved by Euler. Now, let us proceed to the second proof. Consider p is equals to 1 plus 2 plus 3 plus 4 plus and so on. Separate out even terms and odd terms and merge the odd terms like this: 3 plus 5, 7 plus 9, 11 plus 13, and so on. Now, this even terms will give you 2p, and the odd terms 3 plus 5 is 8, 7 plus 9 is 16, 11 plus 13 is 24, and you have a 1 here. Now, your p is 2p plus 1 plus 8 times of 1 plus 2 plus 3, and now this summation is again p. So your equation becomes p is equals to 10p plus 1, and you can conclude that p is equals to minus 1 upon 9. Now, in the first proof, you got the answer as negative infinite, but in the second proof, you got a negative fraction, which is different from the negative fraction proved by Euler. We manipulated this series step by step, and somewhere in this process, mathematics secretly broke. And depending on how I manipulate the infinities, I can force completely different answers. I can make infinity behave like a finite number. I can make positive quantities become negative. I can even create contradictions where the same expression equals to completely different values. And that is the terrifying thing about infinite series. Your intuition starts betraying you. Rules that work perfectly for finite sums suddenly become dangerous because With divergent series, rearranging terms is not always allowed. Grouping terms is not always safe. Factoring expressions can silently destroy the logic. So now the challenge is yours. Somewhere in the proof, there is a hidden mistake, a single illegal step disguised as ordinary algebra. Can you find it? Pause the video, look carefully at every manipulation, and comment below exactly where mathematics broke. Because in mathematics, the most dangerous proofs are not the obviously wrong ones. The dangerous proofs are the ones that look correct